Hello and welcome to this video in the R course. In this video, we will be looking at Principal Component Analysis PCA in R. To conduct PCA in R, we use the PRComp function. Let us see what the PRComp function is about. The PRComp function performs a principal component analysis on the given data matrix and returns the results as an object of class PRComp. It is very important, guys, to know and to understand that we need to pass a matrix only as an argument in the PRComp function for it to be able to do PCA analysis in R. Clear? You have another function called printcomp which does the similar stuff. We will be looking at the PRComp function in this video closely. The data frame or the data that we will be using is the iris data. The iris data structure is right in front of us. It has 5 variables with 150 observations. It basically tells us about the sepal length, sepal width, petal length and petal width of 3 species of flowers. Clear? So we will convert this data frame into a matrix and keep only the numeric part of the data, which is the first 4 columns. To do that, we pass the argument data1 and we assign it as a matrix and pass the first 4 columns only. If you want to do it only for a particular species, then this is the code that you might use to create your data. All right. But right now I'm doing it for all the species across. There are 3 species as mentioned, Setosa, versicolor and virginica. I am doing it for all of them. In case you want to do it for a particular species, please feel free to use the code which is in line number 7. Clear? So the data has been converted into a matrix because the PRComp function can only take matrix form of data as an argument. Clear? So now I will be conducting the principal component analysis using the PRComp function. And we will save the output in a variable called PCA1. You can see that the variable has a list of 5, that is 5 things that are there in this variable, and we'll see each of them one by one. Clear? You can see here when I type PCA$1, I get PCA$1, I get 5 drop downs, and we will see each and every item in it in depth. All right. First item that we want to see are the eigenvectors. Eigenvectors that are calculated can be seen through PCA$1 rotation. The moment I execute this command, you can see that it has the 4 principal components and you get the data for each and every sepal length, width, petal length and petal width as per the analysis done by R for eigenvectors. Clear? You might be asked to perform this kind of an analysis or calculate the eigenvalues or eigenvectors by first principle, in which case you can use the 2 functions eigen to get the eigenvalues and t to get the transpose of the matrix. So you can see here when I execute eigen, you get a spectral decomposition of a matrix. That is what we got here, which computes the eigenvalues and eigenvectors for numeric or complex matrices. Again, you can pass only a matrix through this function, and the t function will help you get the transpose of a matrix if you want to do it by first principle. Clear? PCA$1x, the x element in PCA1, that is a principal component analysis object that we created, will give you the PCA decomposition matrix with all the values for the 150 observations that we had in our data. Clear? To know what center and scale were calculated, we can use PCA$1 center. And we can see the 4 centers that were used or that were subtracted from the 4 components are given right in front of you. When we do PCA$1 scale, the answer comes out to be false, which means that R did not divide the values. All right. So it did not scale the values, or maybe divided it by 1. In essence, it did not have any impact on the values per se. Clear? When you do summary PCA1, it gives you the percentages of contribution from all the 4 factors or as many factors that are there in your principal component analysis. You can see here that the first factor contributes 92.46%, the second one 5.307, the third one 1.71 and the last one 0.5%. So you can clearly see that the first two, or rather the first one itself, contributes maximum amount in the analysis. So you might choose to drop PC3 and PC4 in your analysis. Clear? Last thing that we look at here is plotting the variances. Plotting the variances of all four factors. You can see here that after the first value itself, it has kind of stabilized over here. You can see the standard deviations also. Yeah. And if I square them, you can see for first one it is 4.228, which you can see here. Second one is 0.24, 0.078, 0.023, which almost flattens out or is similar. Clear? So this is how a simple PRCOM function can do everything in principal component analysis that we have studied in our chapter. So please go forward and try it for yourself. Thank you.